Alright, so in this video we're going to look to see how to do the solutions for our quiz here for 6-1 to 6-3. So just remember that when we do these, that the order of my problems might be in a different order than yours. Alright, so here we're going to start out with a Venn diagram. So it says the above Venn diagram is an example of two. Now we got to figure out, are these mutually exclusive, overlapping, disjointed, independent, dependent? Alright, so these are two events and there's overlap. They do have something in common. So we're going to say overlapping events because they have a sum less than 1, they have a sum of 1, they have a sum more than 1, there's an intersection, or they don't have overlap. So the reason why here is because they do have an intersection. They have something in common that's overlapping. So that would be your answer for that first one. Alright, here's another Venn diagram. It says use the Venn diagram to find the following probabilities. Leave your answers as decimals. Alright, so we want to find the probability of A intersect B. So what this means is this is what's the probability of the intersection. So the intersection here, we have the probabilities are listed in each of these three sections. So the intersection is what they have in common. So your answer would be 0.02. Probability of A. Now some of you guys said 0.35 here. 0.35, remember, is incorrect. We talked about this in the warm-up. It was in the assignment, so you should have been able to check your answer online. But A is all of this circle. Now, if you had me in class, I might have mentioned something like, we don't have a scenario here, but let's say A was a probability of people in our class having a dog. Let's say 35% of you have a dog. Let's say 43% of you have a cat. And let's say 2% of you have both a dog and a cat. So the way that we would read this is there's 35% of you guys that have only a dog, but some of you guys have a dog, but you also have a cat, so you'd be right over here. So we'd want to include you when we talk about the probability of having a dog. So we'd want to have all of this together. So we would add those two together and get 0.37. A union B, that's what this is saying. The U means union, meaning that we're going to combine everything together. So those that only have a dog, I'm just throwing that out there as an example, those that only have a cat and those that have both a dog and a cat. So when we add all three of those together, you end up getting 0.8 or 0.80. Whoops, either one would be correct. Now the probability of not B. Now the probability of not B, remember what that represents is that represents a probability 1 minus the probability of B. Because remember, 80% of it of the data is represented here. So that means there's 20%. If this was a dog and a cat example, that means there'd be 20% of you guys that didn't have either a dog or a cat. That's outside of this Venn diagram or not included in this Venn diagram. So the probability of not B. So to figure this out, we're going to take and add together. We got to figure out what's in all of B. What's the probability of having a cat? If we stuck with that example, so we would have 0.02 plus 0.43 would be 0.45. So you have 1 minus 0.45. Which, when you do that, you end up getting 0.55 as your answer. So that's how you do that with the Venn diagram. All right, so this one, we're going to need this dice sheet. Okay, so I remember I gave you guys this sheet. You guys have access to this. You can use this at different points. Like this would be a good time for it. It says, suppose a pair of die is rolled. Determine if the events A and B are mutually exclusive, independent, or dependent. All right. So if it's mutually exclusive, that means that there's overlap. Okay. If it's independent or dependent, we'll get to that here in just a second. But so it says find the event A. So if event A is that the first die is a 5. Okay, so we want to write our answer as a fraction. So the first die being a 5 would be this column. Okay, so that happens 1, 2, 3, 4, 5, 6 times out of 36, which reduces to 1/6. Now event B is the sum is odd. So the sum is odd would be, so 1 plus 1 is 2. That's not odd. Odd are numbers like 1, 3, 5, 7, and 9, and so on. So here, this would be an odd sum. That's a sum of 3. Sum of 5 is right here. Sum of 7 is right here. Sum of 9. sum of 11. So it should be half of them. Let's just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Sure enough, 18 out of 36. We're going to write our answer as a reduced fraction. 18 over 36, like I said, reduces to 1/2. Now it says find the probability the first die is a 5 and the sum is odd. So what's the probability of both of those happening at the same time? So yellow and blue make green, so it makes it easy to find. So we have 3 times out of 36 where the sum was odd and the first die was a 5. 5 and 2, 5 and 4, 5 and 6. So that's 3 times out of 36, which reduces to 1/12. All right, we know that they're not mutually exclusive, because if they're mutually exclusive, there would not be overlap, and clearly there's overlap here. So now to be independent or dependent, to figure that out, we're going to use that formula. Remember, that's the probability of A times the probability of B equals the probability of A and B happening at the same time. Then they are independent. I'll just abbreviate that IND. So they're going to be independent if probability of A times probability of B is the same as the intersection of A and B. So we found the probability of A to be 1/6. We found the probability of B to be 1/2. And if you multiply those together, we get 1/12. And we found that the probability of A and B happening at the same time was also 1/12. Sure enough, they are equal to each other. So we are going to type in just the letter I for being independent. All right. So this one, it says two fair dice are rolled. So again, we might need to use this table here. So I'm going to erase some things. All right. 2 fair dice are rolled. What is the probability that the sum of the die is greater than 8? Okay, so if the sum is greater than 8. So I'm going to mark on here where all those points are, where all those dice would have a sum greater than 8. So greater than 8 does not include 8. Okay, so we don't want to include the 6 and 2, or the 5 and 3, or the 4 and 4, or the 5 and 3, or the 6 and 2. So everything below this line right now, these all have a sum greater than 8. So how many is that? That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 out of 36, which that reduces because 2 goes into both of those, so that reduces to 5/18. So again, we're going to write that as just 5/18. All right, so this one is one we're going to need a tree diagram. So it says Mr. Murphy has 4 children and all 4 are girls. Assuming the likelihood of a boy or girl is equally likely, what is the probability of having 4 girls? So to do this one, you might want to use a tree diagram. So for my first child, we could have had a boy or a girl. Okay, that's for the first child. For a second child, we could have had a boy first, or for the second child, we could have had a boy or a girl. Or we could have a girl first, which is what happened, and then we could have had a boy or girl second. For our third child, we could keep these branches going. Again, the reason why I'm doing all of this, you're wondering, why are we doing this? Because all we care about is getting girls. And we want to figure out the total possible outcomes, and this is one way where we can do that. Or if there was later another question that asked this, we could refer back to the same diagram. But this is how we would create a tree diagram, if you can read my sloppy handwriting here, because I'm doing this in a hurry. But we can, whoops, there we go. Okay, so if I count up how many total items we have in this bottom row, that is a total number of possible outcomes. All right, so we would have 1, 2, 3, 4, 5, 6, 7, 8. So that means we're going to have a total of 16. 9, 10, 11, 12, 13, 14, 15, 16. And so there's 16 total possible outcomes out of, and there's only one, or I should say not out of, but we have 1 out of those 16 is the only way that we could have all 4 girls. So it says write your answer as a percent. So on my calculator, I'm going to take 1 divided by 16, and we do that, we get 0.0625. Which as a percent would be 6 1/4. It says to write it as a percent without rounding, so in that way we don't have to deal with whether it should be 6.3 or just 6. we'll just write it as 6.25, and the percent sign is already given to us. Number 6, 2 fair die rolled. What is the probability? The first die is even, or the sum of the die is greater than 8. So I'm going to go back up here. And so we want to find the probability that the first die is even. So that happens half the time. So that could happen here, here, or here. So that's going to be, we'll leave that because we're going to have to do some adding, subtracting here. So that happens if you count those up 18 out of 36 times, the first die would be even. All right, what is the probability the first die is even, or the sum of the two die is greater than 8? So we just had that. And that was what, 10, I think, out of 36? Okay, so now we want to see, is there any times where we have a sum greater than 8 where the first die was also even? So first die is even right here. So we have 2 times there where we have the first die being even and a sum greater than 8. And we also have these 4 times. So we counted those 6 outcomes. We counted those twice. So we have to subtract that. If you didn't subtract that, you lost half the points. So when we add these together, 18 plus 10 minus 6 gives you 22. So we'd have 22 over 36. It says to write our answer as a fraction reduced form. So now I see that 2 goes into those, so it reduces to 11/18. That would be your answer for this one, number 6. Okay, let's look at number 7. So here it says, a quiz consists of 4 true or false questions and 3 multiple choice questions with 4 choices each. How many different ways are there to complete the quiz if you guess at every problem? So we want to figure out, first off, how many different ways there are to complete this test. So again, there's 4 true or false questions. Each of them had 2 choices each. So here's one way we could do it. Okay, so we have 4 blanks. Each of those blanks represent a true or false question. Each one of those, we have 2 possible options. You could have true or false. And we would multiply those together. Or we could just say that's 2 to the 4th power. And then we multiply that times, so there's going to be 3 multiple choice questions. Each of those multiple choice questions has 4 choices each. Again, there's 3 of those. So we could have 4 times 4 times 4. Otherwise, the way that I would write it is like this, 4 cubed. So again, the base represents the number of choices. The exponent represents the number of outcomes. So we'd have 2 to the 4th times 4 cubed. And when you do that, you get 1,024 different ways you can complete the quiz. So no commas, just type in 1,024. What is the probability of guessing and getting all the answers correct? Well, there's only going to be one way to do that. There's only one correct answer key, so it'll be 1 over 1,024. And if you do that on your calculator, we get, so now we want to make sure you know how to round to a good decimal, because it says round nearest 1/10 of a percent. So we have 0.000977. So that's as a decimal. If I change this to a percent, I'd move the decimal 2 places to the right. So we would have 0.0977, but it says round to the nearest 1/10 of a percent. So that'd be 0.10 or 0.1%. All right, number 8. For your birthday, you're going to a restaurant that has a special birthday offer of a 4-course meal. It says the meal consists of 3 choices for an appetizer, 2 choices for an entree, 5 choices for a main dish, and 4 choices for a dessert. All right, so let's see. So we're going to choose one of each of these. So we'll figure out how many different meals you can select from. So there's 3 choices for an appetizer. Okay, so we'll use that first blank to represent appetizers. This blank is going to represent the entrees, and there's 2 choices for an entree. This blank will represent our main dishes. So we have 5 main dishes to pick from, and this will represent our dessert. So we have 4 desserts to choose from. So if we multiply these together, so 3 times 2 is 6, 6 times 5 is 30, 30 times 4 is 120. So there's 120 different ways or different meals. Last question. 2 fair dice are rolled. What is the probability that the sum of the die is 5 or an 8? Okay, so let me erase this. 5 or an 8. Now we got to ask yourself, okay, so I see the word or. All right, so if it's or, we're going to add 2 probabilities together. But I got to figure out, is this one where I'm also going to have to subtract a number? And so I need to ask myself, is it possible for me to roll both a sum of 5 and a sum of 8 at the same time? No, that's not possible. I'm only going to either roll a 5 or an 8. So I'm going to have two separate fractions I don't have to add, or I don't have to subtract in intersection. So the sum of 5 happens 4 times out of 36. A sum of 8 happens right here. That happens 5 out of 36 times. So if we add those, we get 9 out of 36, which actually reduces to 1/4 of the time. So we got to write it as a reduced fraction, so 1/4. And that's it. So hopefully going over those questions helps you understand what you did wrong for the ones that you did not get correct on the quiz. If you still have questions, please make sure that you talk to me and reach out. So in that way we can sit down together and make sure you can figure out how to do these, and I can give you some pointers and hopefully send you in the right direction as far as how to do better for the quiz, or for the next quiz and for the test.